So what is the Ethereum virtual machine? All right. So the Ethereum virtual machine, or EVM, is essentially a runtime environment for smart contracts in Ethereum. All right. It's not only sandboxed, but it's actually completely isolated. All right. So what does that mean? Well, it means that the code running inside the EVM actually has no access to network, file system, or any other processes. Smart contracts even have limited access to other smart contracts, and we can define how the access works, and we're going to see how we do that in Solidity with special keywords together in this course. Okay, so when we're thinking about EVM, the Ethereum virtual machine, there are essentially two kinds of accounts in Ethereum which can share the same address space. All right, so external accounts that are controlled by this public-private key pairing, and that's, for us, that belongs to the investors, to the holders, so us. And then we have the contract accounts, right? And the contract accounts are controlled by the code that we're going to build as developers, and that code is stored together with the account. So when we make a contract, like we are going to many times in this course, when we make a smart contract and we deploy that contract, then that contract gets an account, okay? And in order to deploy that contract, we use another account. We're going to use our own accounts to actually deploy the contract. So we have our own accounts, and then we have the contract accounts, okay? And again, this is something that we're going to be seeing in real time and doing together, so don't worry if you're unsure so far. The address of an external account, it's important to note that that is determined from the public key, while the address of a contract is determined at the time the contract's created. Interesting, right? So we have a key that we use to send over. If we want to send Ether from one account to another, we're going to use the public key. Now, when we want to bring up the contract itself, that account is actually going to be from the time that the contract is created. All right. And it's derived from the creator address and the number of transactions sent from the address. Okay. They call that the nonce. All right. So regardless of whether or not the account stores code, the two types are, of course, treated equally by the Ethereum virtual machine. All right. Every account has a persistent key value store mapping, right? And we're going to go over mapping together and what that means, because we use mapping to essentially create key store values in Solidity, and it's a very powerful index hash tool. Okay. And furthermore, every account's going to have a balance. Right, and the balance is always set in way, and we're gonna learn what way is. Way is essentially the smallest denomination of what Ether is. Okay, it's the 18th decimal place of what Ether is, and we're gonna learn why this is important, why we have these metrics set up this way, and how we can leverage this for our own best interests as we continue along. All right, so that's it on an introduction to EVM, the Ethereum virtual machine. I hope this gives you a taste and understanding of the addresses. If you have any takeaway here, at least remember that we have two types of addresses. We have the external accounts for people and the contract accounts for the contracts that we code. Okay, and we're going to learn, and we're going to get the hang of this as we go together and actually do the coding together. So don't worry, not too much more jargon and chit chat. We're going to get to the actual coding soon, I promise. All right, so now that we have a brief understanding of what blockchain is, of what a blockchain is, let's go ahead and actually discuss how does a blockchain actually work. All right, so let's use this analogy. So imagine we have a large room, all right, with briefcases on one end and glass on the other end. All right, so each briefcase has a lock and a chain that connects it to the next briefcase, right? So we've got one briefcase connected to another briefcase connected to another by lock and chain, all right? Now, everyone can see the briefcases because the glass is transparent, so we can see through this transparent glass, all right? But only the person who has the key to one of the briefcases can actually open the briefcase. All right. So suppose that I want to transfer some money, all right, some cryptocurrency from my briefcase, so from one of the briefcases to your briefcase, what do I need for that? Well, I'm going to need effectively a key, right? So that's going to be the key to the briefcase. So that's going to be crypto to open and then to sign to verify the transaction. Okay? So looking through the glass, we can see that the transaction will belong to me along with the details of the transaction as soon as it gets to you, the other person who I'm sending it over to. So we broadcast in that way to everyone that you have received your money, and everybody takes a note of it, right? It's kind of an interesting, funny thing to think of, everybody taking this note when the transaction occurs. But that's effectively what happens. So after a period of time, someone's going to gather all these mini transactions and collate them into blocks. And those are then added to the chain, all right? So at a very simplistic level, this is essentially how a blockchain works. Hopefully that makes a bit of sense. Using some imagery here, you can actually get a better picture and understanding of what we're talking about. We're talking about a series of blocks that are chained together, like we said. So a block and a chain, all right? It consists of these two things. And we're referring to a block as a collection of transactions, and the chain being the mechanism which ties them together, right? So, that's what checks to see that the block signatures are valid. All right. So each owner transfers Bitcoin, let's say, if we're talking about the Bitcoin blockchain, to the next by digitally signing a hash of the previous transaction and the public key of the next owner, and then adding these to the end of the coin. All right. And then that way the payee can verify the signature to verify the chain of ownership. And that actually comes from Satoshi Nakamoto's Bitcoin white paper. So if you want to go and read really about blockchain, then you should really go to the Bitcoin white paper. And I'm going to provide a link. And that's the first one. That's the mother of all blockchains. And you can go there and read and get that fundamental understanding of a blockchain, because it does parachute and its way over around to all the other blockchains which are which we consider, including Ethereum, right? Which is what we are going to be building our smart contracts off of. So that's it. So hopefully that gives you a better sense of how a blockchain works in terms of blocks and chains, in terms of the transparency level with the glass, in terms of sending transactions, keeping track of it, and then updating the blockchain. All right. It's a simplistic way of looking at it, but it should be an effective way for you to get a better understanding, because as application developers, we need to at least have an understanding of how this is working in the back end, because we are building the smart contracts that are connecting, and then we are interacting with blockchain technology. So it's good to have at least this foundation sorted out. So hopefully that helps you out, and I'll see you in the next video. All right, so what is crypto mining? Right? We hear this term about crypto mining. You're mining to find more Bitcoin. You're mining for Ethereum. What is crypto mining? So crypto mining, essentially, it's just a process of verifying if a block is valid. All right? And that's done by nodes. All right? And those nodes are called effectively miners. So cryptocurrency mining is actually a term that refers to the process of gathering cryptocurrency. And then you get rewarded for completing that work, all right? And so whether that could be known as Bitcoin mining, for example. And whenever these transactions are made, all the network nodes will receive them. And then they verify the validity, okay? So miner nodes, they go to collect all the transactions from a memory pool and then attempt to organize them into the blocks. Excuse me. So the nodes perform a series of hashing functions. So these are really difficult mathematical problems. And then that is set up to these protocols by crypto networks until it finds a valid hash. And when it actually solves the problem, it's got the hash, then the node will broadcast the block to the network. Like Bam, we did it. We got it. Boom. All the other nodes then check to see that it's valid. And if it is valid, then that block gets added. All right. So you add the block into their copy of the blockchain. All right. So this is hashing the transactions to form blocks. And it poses a problem in terms of energy usage because it really does require a lot of computational power. So because of that, the nodes that perform these hashes get rewarded for their efforts. All right, and they get rewarded in the currency. Okay, so that in effect is a nutshell of crypto mining. Nodes can combine together to pool resources, and then the currency is rewarded and shared amongst them. All right, or the currency is the reward. So this isn't a course on crypto mining, so I'm not going to get any deeper than that. But of course, you can, if you're interested more in the crypto mining aspect of what goes on in blockchain and the mining, the verification of transactions, the process, the hashing, the computational power that's involved. Stuff is really interesting. It's very cool. I totally agree. So go scope it out for yourself if you're interested. But again, we don't need to have a deeper knowledge than that in order to build our applications. This is not the core functionality of what we're learning in this course. We're learning how to build the smart contracts. We're learning how to get a job right now in an industry that really needs smart contract developers. And so at the bare minimum, at least having this fundamental of what crypto mining should be great, should be good enough for you to keep moving ahead. All right. All right. So we now covered what is a smart contract. Let's also cover one of my favorite topics, non-fungible tokens, NFTs. And if you want to take a deep dive into NFTs, I actually have a course with TJ Walker where we go into a full course on NFTs, how to make them, how to deploy them, how to, or mint them, that's how we would say it, how to mint them, how to trade them, and then a lot of different interesting aspects of how it affects the world for artists, for musicians, for content creators, investors, managers, publicists. It's a really detailed course. So if you're interested in NFTs and you've been hearing a lot about that, you can go check out the complete non-fungible tokens course that TJ Walker and I have. But since this is a course on applications, we should at least have a brief understanding of what NFTs are. So NFTs stand for non-fungible tokens, and they are essentially unique digital assets. So they're different from other cryptocurrencies for one major reason. They are not fungible, okay? So something that is fungible is like money, right? It's something that you can exchange. It's interchangeable. If I give you a $5 bill and you give me five $1 bills, it's the same thing, right? It's exchangeable. But if I give you a Picasso painting and then you give me a slice of pizza, that's no longer the same thing. These are two things, you know? Or even if I give you a Picasso painting and then you give me, let's say, I don't know, $5 million or whatever it is, that painting itself is still non-fungible, right? It's not interchangeable. I can't cut that painting up into pieces. I don't want to do that. You don't want to do that. So a fungible asset is one that is indistinguishable from one another, all right? So with NFTs, the value is unique because it's based on the NFT. I could digitize a painting and I can turn it into an NFT and then issue it out, and that's very powerful for artists. And again, if you're an artist and you're interested in learning how to do that and why this is so powerful and important, then go check out the course. I know I've been, that's a lot of me saying like a lot of promotion there, but I'm really proud of that course. It's great. So people that purchase NFTs, you know, if they purchase your NFT, they're going to have a digital version of the painting if you made a painting into an NFT. All right. So finally, how do we actually assign value to an NFT? Well, with all things in life, the value is determined by how much people think it should be. So you can run auctions, and then based on the auctions, people can say, well, I love this painting. I'm going to auction up for that NFT. So it is a digital asset. That's what an NFT is. And why is this relevant to applications? Well, because it belongs on the blockchain, right? And you can now already hopefully understand or imagine there's so many applications and use cases that already are being built and that need to be built for NFTs. Very, very exciting topic, very hot topic, and really cool. All right, that's it on NFT. All right, so let's talk about proof of work versus proof of stake. And this is something that you may have heard often when we talk about Ethereum. Oh, Ethereum is proof of stake. Bitcoin is proof of work. You know, you can hear this if you're into cryptocurrency, but maybe you don't actually have an understanding. Sorry, I just had to move the mic a bit. Maybe you don't have an understanding of what this actually is. So let's go through proof of work versus proof of stake and the security mechanism behind it and why this is so powerful. So one of the challenges when it comes to distributed systems is how do we ensure honesty? How do we ensure that every node in the network is being truthful? That the miners of the blocks do not just bring false information, false blocks, and they don't actually do the work. They don't actually do the hard hashing and solving of these heavy computational energy consumption work that they have to do. So the answer essentially can be found in a consensus algorithm. All right. So there are a series of algorithms when we're talking about the consensus algorithm, which govern miners in a blockchain. And all the nodes know this algorithm. So what they do is that they check for the validity of it. You can kind of think of it like a lie detector test in that way. You know, it's a lie detector for the chain. It's checking to see that you're actually going through the consensus algorithm. So it verifies that the hashed block the miner is proposing is therefore valid, right? So what would happen, let's say, if a miner were to bring to the table an invalid hashed block? Well, not only would it have wasted computational time, and we're talking about serious energy, so computational time, it would also be, invalidating its reputation, the resources. It would be a waste of resources. It really is a faux pas. You know, if it brings a valid block, on the other hand, it's just going to get rewarded in the native coin of the blockchain. So it just really does encourage a proof of work ethos having this consensus algorithm. So this consensus algorithm on the blockchain, so it's called proof of work because miners actually have to prove that they've done the work. And I'm a big fan of proof of work personally. I think that it takes up a lot more energy on the one hand, but on the other hand, in terms of security, it is the most secure mechanism out there in terms of security for a blockchain. But let's not stop there. Let's actually take a look at proof of stake as well. So proof of stake, basically, it does something different. Instead of sacrificing all this computation resources, sacrificing crypto coins, what it does, it has a process called staking, all right? And essentially what it does is that it's going to be sacrificing crypto coins instead of computational resources, all right? So a pseudo-random node can be selected based on some conditions, all right? And that's to forge a new block. The node then will stake a percentage of its coin as a down payment, all right? And that's what's actually going to forge the block correctly. So when the node completes the block, what happens is that it gets rewarded with transaction fees for its work, all right? Now, if it tries to cheat by not forging the block correctly, again, it's risking its stake and it's risking its reputation. All right. And then with proof of stake, we have this halving. And halving is basically a process whereby the reward miners, they get rewards. But when you do the halving, those rewards then are reduced. All right. So that's when reward miners actually have their mining rewards reduced. And this is done actually to deflate crypto coins. So I don't know if you've heard about the Ethereum halving and then the miners kind of protesting the halving and the propositions that we've been hearing and talking about, but essentially that's what's going on. Halving is just that process whereby the reward miners get for mining is reduced. That amount gets reduced. And the reason why they do this is actually to reduce the total value of its crypto coins in circulation for a blockchain. Now, which one is better? Which one is worse? Well, proof of stake clearly is going to take far less computational energy than proof of work, right? But on the other hand, proof of work, you really have to use this consensus algorithm. So in terms of actually the security and checking for the validity, it's much more rigorous. Therefore, it is more secure. Now, is that to say that proof of stake isn't secure? No, proof of stake is still actually can be quite secure. There's so many reasons to set up the blockchain and do it in a very secured fashion. But it's just something to consider the two. So I'm not going to say which one I think is better or worse and all of that and what it means or doesn't mean. I'm not here to do that. I just wanted to open up these ideas for you so you have a better understanding of proof of work versus proof of stake when people talk about this in crypto and in blockchain, because we are effectively, as developers, working with blockchain, so it's good to have that information.